Welcome to Kapardi Maths Classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 7th video on full calculus as a part of a real analysis. In this video, I am going to discuss about algebra of functions. So, what is the meaning of algebra of functions? How to add two functions, how to find the difference of two functions, how to find product and the division of the functions. Let me explain one by one, and then later I will tell you what is their domain and range. Let F maps df to Rf and G maps domain of G to range of G or 2 functions. Then what is the sum? F plus G of x is equal to f of x plus g of x. Number 1. Number 2, f minus g of x is equal to f of x minus g of x. And finally, the product fg of x is equal to f of x times of g of x. Next one, f by g of f is equal to f of x by g of x, but the condition is my g of x is not equal to 0. So, you can apply other operations also, find square root of a function, nth power of a function, everything you can do. But here, look here, I define only one function, root f of x is equal to root of f of x. Only this I introduce. Okay, now these are the definition of the functions. Then what are the domains of these functions? That is next one. Now listen carefully. Domain of f plus g is nothing but domain of f intersection domain of g. Next, second one, domain of f minus g is a domain of f intersection domain of g. And next one, we have domain of f times g is also domain of f intersection domain of g. And next one, domain of f by g is also domain of f intersection domain of g, but you have to remove those x values for which g of x is equal to 0. Now, next one, domain of root f is equal to x such that f of x more than or equal to 0. Next one, domain of 1 by f is equal to r minus, or I can say domain of f minus x such that f of x is equal to 0. And finally, you have one more, domain of 1 by root f is equal to x such that f of x greater than 0, here greater than or equal to greater than 0. If you remember these 7 rules, you can find a domain of any function. Please take it, and next we do examples. Find the domain of definition of the functions. First question is f of x is equal to root of x minus 1 plus root of 6 minus x. Solution. My f of x is under root of x minus 1 plus under root of 6 minus x. My function f of x looks like addition of the two functions. So, you have to find domain for this function and domain for this function, then you have to find intersection of the domains. So, that is number 1. Okay. F of x is sum of two functions, say f1 is equal to f1 of x is equal to root of x minus 1 and f2 of x is equal to root of 6 minus x. Therefore, domain of f is equal to domain of f1 intersection domain of f2. Now, I am going to find domain of f1. Now, domain of f1. f1 of x is equal to under root of x minus 1. Now, my function f on x is again square root of. Now, what is square root of the function? Domain of root f is defined as x such that my f of x is more than or equal to 0. Is the definition? So, here my f of x is x minus 1. Therefore, here domain of domain of root of x minus 1 is equal to x such that x minus 1 more than or equal to 0, and this is just nothing but 1 to infinity. Next one, come to second one. Now, domain of f2 of x is equal to under root of 6 minus x. So, here also same rule, therefore, is equal to x such that 6 minus x is more than or equal to 0, or I can say 6 minus x more than or equal to 0, or implies x less than or equal to 6. This implies my x belongs to minus infinity to 6. Now, the final answer is domain of root of x minus 1 plus root of 6 minus x is equal to, first one I got 1 to infinity intersection, second one I got minus infinity to 6. Now, to take the intersection of these two intervals, I will take help of real line. The first one is 1 to infinity, somewhere here 1 to infinity, like this I will take. Next one 6 to minus infinity to 6, somewhere here minus infinity, and this is equal to 6. Now, the common part of these two intervals is this. That is nothing but 1 to 6 is equal to 1 to 6. Can I take 1? Can I take 1? Yes, I can take. If I take 1, 1 minus 1 is 0, root 0 is valid. Can I take 6? Yes, I can take 6. 6 minus 6 is 0, so root of 0 is also valid. So, finally, my answer is this. That's the answer. So, this is the first question. That's why I explained each and every step. From next question onwards, we can move. Next question is, find the domain of under root of x square minus x minus 2 plus 1 over root of 3 plus 2x minus x square. Method is just like the previous one. So, first I will find domain of this function, then I will go for domain of this function, then I will find intersection of those domains. So, first of all, domain of, I do not write any unnecessary steps, domain of under root of x square minus x minus 2 is just nothing but x such that my x square minus x minus 2 more than or equal to 0. So, take x square minus x minus 2 more than equal to 0, this is same as x minus 2 times x plus 1 is more than or equal to 0. So, this implies my x belongs to minus infinity to minus 1 union 2 to infinity. That is number 1. Next one, domain of 1 over under root of 3 plus 2x minus x square is equal to x such that 3 plus 2x minus x square just greater than 0. Why? Because 1 over. Okay. Now, therefore, take 3 plus 2x minus x square greater than 0, and this is same as my x square minus 2x minus 3 is less than 0. Therefore, my x belongs to minus, the roots are, you say, 3 and 1. So, x belongs to minus 1 to 3. Minus 1 to 3. Now, this is number 2. You have to take intersection of 1 and 2. Therefore, domain is equal to first one minus infinity to minus 1 union 2 to infinity. This is number 1. Intersection minus 1 to 3. Now, we are going to take intersection. Again, I will take the help of real line. Minus infinity to minus 1 somewhere here, and 2 to infinity somewhere here. Next one, minus infinity to 3. Here, this is. Now, common to these two intervals, if you observe carefully, is the part. This part. So, the answer is equal to 2 to 3. 2 here is included, so I will put closed one, and 3 is excluded, so I put 2 open. So, the answer is 2 to 3, 2 close, 3 open. Please take it.